Hi everyone, I hope you are safe and healthy. I would just like to carry on where we left off in class last time. The adding and subtracting of algebraic expressions. Last time we learned how to identify and collect like terms. So specifically here, let's remind ourselves, in an algebraic expression, terms are separated by plus or minus signs. Only like terms may be added or subtracted. So how do I identify like terms? And that is when terms have the same variable with the same exponent in each. And now let's look at a few examples of such expressions. 2x and 3x would be considered like terms because both have the x that are the same, and the exponents, although nothing is written, would be a 1 and a 1. So the rule is then we may add them together. And what do we add together then? The part that gets added would be the 2 coefficient and the positive 3 coefficient. So 2 and 3 gives you 5. And therefore your answer would be 5 x's. Right, so in the next expression we have x and x, exponents 2 and 2, so x squared and x squared are like terms. We can add the 9 and the 11, and that gives you 20x squared. Notice how the variable part, which was alike, stays the same. Last example of like terms expressions, we have y, which would be considered as 1y, plus 2y plus 3y, and then that means 1 plus 2 plus 3, because they're all like terms, gives you 6y. Lastly, on this page, I have examples of expressions containing unlike terms, and that would be in the first part, 2x plus 3y, quite obvious unlike terms, because it's x and y, the variables aren't even the same. How would you write this answer if I gave you such an expression to simplify? You can't simplify it, so you just write 2x plus 3y. Then, on the second example, although both of the terms contain an x, the exponents are different. The first term x has a 2 as an exponent, and the second one has a 1. So we aren't able to simplify that or add them together. And your answer would then stay 9x squared plus 3x. And then in the last example here, 5x plus 1 is a constant term being added to an x term or a variable term. We can never simplify such an example. So the answer would stay 5x plus 1. Right. Moving on to adding expressions. So as you can see in this, we have 2 expressions being added together. So to add them together, we would have to remove the brackets. And how we do that is by saying 1 times the brackets values inside and 1 times the values inside the brackets. So it's by using the distributive method that we apply this. So firstly, 1 times 14x, if multiplying by 1 changes nothing, then we can actually just simply take away the brackets. 14x minus 6y, and the same goes here. Remember, multiplying by positive 1 yields the same answer. It is, oh, that's a mistake. Let me just take it away. Okay. So that would give you positive 3y plus 9x plus 2z. So to simplify this, we would firstly identify like terms. The x and the x would be alike, the y and the y, and then the z is on its own. We have nothing to add to it to simplify it with. And therefore, if we add those like terms together, 14x and 9x all together gives you 23x. And then negative 6y and positive 3y gives you negative 3y, and lastly plus 2z. Okay, and that's the simplest form of that expression. Now I want you to pause and try example number 2 on your own, and then when you play, you check your answer. So firstly, we get rid of the brackets by multiplying by 1, and multiplying by 1 means everything that was inside the brackets stays the same. Now we get the like terms, so x and x, y and y, and z has a buddy this time around z and z. And now we can put them together where possible. 12x and 6x all together gives you 18x. Then the y's, negative 2y, remember the signs in front of each. Negative 2y and negative 9y gives you negative 11y. And then the z terms would be 3 and negative 2. 3 minus 2 gives you positive 1z. I'm writing the positive 1 in for you until you're used to the convention that we don't write 1 in front of the variable if the coefficient happens to be 1, or positive 1. Right, so that's the simplest form of that expression. Moving on to this, what's the difference between example 3 and 2, like the expression here, we're subtracting an expression from a certain amount of terms. So, in other words, this time around, we have a negative 1 in front of this set of brackets that we have to multiply with each term inside the bracket. So the first part stays the same. So it's 3a and 2b and negative c that we're subtracting whatever the answer of multiplying negative 1 is of all of that. So negative 1 times 2a is negative 2a, and then negative 1 times negative 4b. Let's break it down like I taught you. We multiply the signs with its special rules, the numbers and the variables with their special rules. So negative times a negative is a negative, positive, what? Then 1 times 4b is 4b. 1 times anything stays the same. Then, for the last term in the brackets, negative times a negative is a positive, and 1 times 2c is 2c. Let's collect, or firstly, let's select like terms. 3a and negative 2a go together, 2b and 4b go together, and negative 1c and positive 2c goes together. So now we can simplify by adding the like terms. The a terms, 3a and negative 2a is positive 1a. I will still write the coefficient 1 for you. 2b and 4b gives you 6b positive. That is positive 6b. And then negative 1c and 2c, once again 2 minus 1 gives you positive 1c. Right, I want you to now try example 4 on the next page by yourselves, and then so you're going to pause and then play again to check your answer. Okay, so firstly we multiply the negative 1 that's in front of the brackets by each term inside the bracket. So it becomes negative 3k. Then a negative times a negative is a positive. 1 times 6m is 6m. And then in the last term, a negative times a positive is a negative. 1 times 3n is 3n. Like terms would be k and 8k and negative 3k. Negative 3m and 6m. And lastly is 11n and negative 3n. So let's add or subtract these like terms. 8k minus 3k gives you 5k. Negative 3m and 6m together, or 6 minus 3 is positive 3n. So plus 3m, and then 11n minus 3n gives you positive 8. And you can check these answers for the coefficient values 8 minus 3, for example, on your calculator if you're not so sure or not as confident with your integer calculations as of yet. Right, so example 5 is a word problem where they say subtract 5a from 9a. So we first have to write it as a sum, and that would be if we subtract 5a from 9a. So the 5a is written second, first mention will be written last, second mention will be written first. And then we know the like terms, so we can subtract the 5a from the 9a. 9 minus 5 is 4, so it's 4a. A. And then I want you to try example 6 on your own. So pause and then play again to check your answer. We are of course multiplying 1 into the first set of brackets, but into the second set of brackets we have to multiply -1. So 2a minus 9 subtract 9a plus 2, because we're multiplying a negative by negative for that second term in the second set of brackets. So like terms in this case would be the a values that we can simplify, and then the constant values we can simplify. And it gives you 2a minus 9a is -7a, and then a -9 plus 2 is -7 as well. And there we go. So you can carry on to do the worksheet exercise. Firstly, on the next page, I have provided you with some math keywords. Well, if you zoom in, it's not that clear. Hope you can see or make out what it is. And then it follows with the worksheet. I will upload all the solutions next Monday for the week's work that has passed by then. Right, so every day I will post something and let you guys know that it's up, and then you have to do it. Just make sure that you ask if you need help and you know how to contact me.